right, for our first real example of finding the cross product, we'll look at number 18. 18 and the others like it, the ones from 15 to 22, have four parts that they're asking you to do. I'll do a couple of the parts for number 18 for time's sake, and we'll show you how this is to be done. What they've done in number 18 is they've given us a vector v, and the vector v that they've given us is I minus 4j plus 2k, and they've also given us a vector w, and the vector w that they've given us is 3i plus 2j plus k. And they would like us to do a few things. For part A, they're asking us to do v crossed with w. So they're asking us to do the cross product. And here's how you do the cross product. The way that you organize the cross product is you put those variables in that you know you're going to need for this new vector. So remember, the cross product gives you a vector. And so you're going to put the variables I, j, and k, and I apologize, they're not variables. The vector I, the vector j, the vector k. And then you're going to put in a very specific order. V needs to come first. So V is 1, negative 4, 2, and W is 3, 2, 1. Now, having said that, I don't actually think it matters what order you take the cross product of. I think that V cross W and W cross V will be they won't be the exact same thing. They'll be the opposite sign. So it does make a difference which way you put them. So if the V is first, the V needs to be on the second row, and W second, W needs to be on that third row. And essentially all you have to do to find the cross product is take the determinant. And so if we follow that same 3 by 3 determinant that we did earlier, we have this. We will say that it's going to be I times, and then we'll look at negative 4 times 1 minus 2 times 2. So hopefully you're seeing that. Just to show you, we're looking at the determinant of this matrix right here when we're dealing with I, because we get rid of its row and its column. And so negative 4 times 1 minus 2 times 2 is the first one. Then if you remember, we are going to come in here and do a minus sign next, because we always alternate signs. So minus j, and then remember we're going to be looking at these numbers right here and the determinant of those. So we're going to get a 1 times a 1 minus a 3 times a 2. And then we're going to have plus again k. So we get rid of that circled area. And then for k, we're going to do the determinant of what's over here, which is 1 times 2 minus 3 times negative 4. See if I can sneak that in on the side. Okay, I'll start farther over next time. So that's what we have. So I don't know if you can see that very well, but 1 times 2 minus 3 times negative 4. And so what do? We just figure out our i's. And so if we look at the first one, we have a negative 4 minus 4, so that's negative 8i. If we go to the second one, we have 1 minus 6, right? So 1 minus 6 is negative 5. So negative 5 is working out of this one. And a negative of negative 5 is plus 5j. And then for k, we have 2 minus a negative 12. So that looks like it's positive 14. So then times a positive k is positive 14k. And that is the cross product. Now what's interesting with the cross product is the cross product is a vector that is orthogonal to both v and w independently. So the cross product definitely has some unique properties. It forms a vector that meets at 90-degree angles with the two vectors that are being crossed. So that's its big application, and they'll just point that out in later examples, but I'll bring it up here as well. If we go and look at If we go and look at something like C, C wants us to take W cross W. So if you remember, W was the vector 3i plus 2j plus k for this number 18. And so we can cross a vector with itself. They want you to see what that would look like, and you get the same thing every time. So you could probably just see this once, and then every time you're asked to do it as part C, you know what the answer is, because it wouldn't matter what the vector is. Let's see what happens here. You're going to have I, and we'll do this a little bit quicker, times 3 times 2. Oh, I apologize. You wouldn't have that. I wasn't looking at it right, so we'll slow down just a little bit. Remember, we get rid of this one and this one, so it would be 2 times 1 minus 2 times 1. When we go to do the j, it's a minus j, and it would be these outsides. 3 times 1 minus 3 times 1. And then plus k, and k will be those outside ones, those ones I was doing first. 3 times 2 minus 3 times 2. And you can see that what you get is zeros every single time. And so you just end up with the 0 vector. So you end up with nothing. But it is a vector. It's the 0 vector that has no magnitude and no angle as well. It's sitting right on the origin. That's how you do a majority of the problems, and we'll step through others in each of the different sections.